Okay, so today we are going to be working on Lesson 5, Distance on the Coordinate Plane. The beginning of the lesson is a review of how we can find the distance between 2 points on the coordinate plane using their ordered pairs. So in the table, you'll notice that each one is listed as a line segment. So the first one is line segment AB. So they want us to find the distance between point A and point B. So if you go over to your picture, which is at the bottom of your paper, we can use the coordinate plane to find the ordered pairs. So here's our origin. We're going to go 2 to the left until we're under point A, which would be -2. And then we will count up till we get to A. 1, 2, 3, 4, 5, 6, 7, 8. So we know that we are at -2, 8. So point A is -2, 8. For point B, starting at the origin, we count to the right, which means it's going to be positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll count up to B, which is at the same place as A, so we know it's 8. So point B is 9, 8. Now to find the distance between these 2 points, we want to find the number that they don't share in common. So they share the 8s in commons. So if we look at the -2 and the 9, they have different signs. One's negative, one's positive. So when they have different signs, that's when we add together their absolute values. So this is under the proof part. So the absolute value of -2 is +2, and the absolute value of 9 is +9. So 2 plus 9 is 11. They are 11 apart. You can also count between the 2 points. Just remember to start where the point is and go to the other point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just proves that we had it correct. Now the next one I know is kind of hard to see on here, but it should be clear on your paper, is line segment BC. Now we already have the point for B. B is at 9, 8. So if we go over and find C, we'll see it's over the same number, which means it will start with 9, and then we go up 1, 2 until we get to C. It may be helpful for you too also to put points where each one kind of falls so that you know where you're counting from. Most of these we won't get to because we're only going to do a couple of these. So point C then is 9, 2. So the one that they share in common is the 9. So we're going to look at the 8 and the 2. 8 and 2 have the same sign, which means we're going to subtract their absolute values. So the absolute value of 8 is 8, and the absolute value of 2 is 2. 8 minus 2 is 6. So their distance is 6. Again, if you were to common count, you could see from point to point, 1, 2, 3, 4, 5, 6. The next one is line segment CD. C we already know as 9, 2. So if we come over and look for point D, from the origin we see it's over the same number. So again, that's 9. And then it's down 1, 2, 3, 4, 5. So that's 9, -5. Looking at the 2 ordered pairs that are not the same, or the coordinates, it's 2 and -5. They have different signs. So we would add their absolute values together and get 7. And again, if you count between the 2, 1, 2, 3, 4, 5, 6, 7. Now, there's a full table here of problems that we can do like this, but since this is review, and hopefully you should know how to do these, we are going to move on to the next piece. So looking at the next part, it's asking us to plot and connect the points, and then give the best name for the polygon and determine the area. So the first point, letter E, is -8, 8. So what we're going to do is start at the origin. We're going to move over to -8 and then up to +8. And there's E. The next one, F, is -2, 5. So over to -2, up to 5. And put F. And then the last one is negative 7, 2. So over to negative 7, up to 2, and that's point G. So now what we're going to do is we're going to connect those points. I'm going to use my straight edge here so that mine can be as accurate as possible. And then what we have to do is determine what the name of this polygon is. If you look, hopefully you can see that it is a triangle. And all of the angles in this triangle are acute angles, so this is an acute triangle. If you look at this triangle, you're going to see that none of the sides of the triangle are on straight lines where we could count how long they are. So with this problem, we can't find the base and the height based on the lines on the grid. So this is one where we're actually going to have to draw a rectangle around it and then subtract out the empty spaces. So the first thing I am going to do is I am just going to kind of fill in the triangle that we're looking for. And then what I'm going to do is I am going to use my straight edge to create a rectangle that goes through all of the points of the triangle to create a rectangle around it. So notice it goes through each of the points or connects with each of the points. This has created a rectangle, but it has also created 3 triangles. So we've got this triangle right here, this triangle right here, and this triangle right here. So what we're going to do is we are going to find the area of the rectangle by using the formula area equals length times width. We can count this side, or we can use a distance between 2 points, either way. I'm going to just count it. So 1, 2, 3, 4, 5, 6 is the length. And then the width is from here all the way up. So 1, 2, 3, 4, 5, 6. So it is actually a square now that we know it's a 6 by 6. And that would give us 36 square units. So now that's for the entire rectangle, but we're just looking to find the area of this triangle here. So when we created this rectangle around the triangle, it created 3 triangles that use the lines for their bases and their heights. So we can easily count the bases and the heights. So if we look at triangle 1, remember the area of a triangle formula is base times height divided by 2. If we look at this triangle, we have a base of 1. We have a height of 1, 2, 3, 4, 5, 6, or the entire side of the rectangle. And then we would do 1 times 6, which is 6, and divide that by 2 to see that that would have an area of 3. For triangle 2, base times height divided by 2. Again, it doesn't really matter which is your base, which is your height. Depends on which way you're looking at it. So our base here would be 1, 2, 3, 4, 5. And our height is 1, 2, 3. 5 times 3 is 15, which we would then need to divide by 2, which gives us 7.5. For triangle 3, we have a base of 1, 2, 3. Again, remember your base and your height are interchangeable, so it really doesn't matter which one you put as the base, which one you put as the height, for right triangles anyway. 1, 2, 3, 4, 5, 6, or the entire length of the square. And then 3 times 6 is 18, and 18 divided by 2 is 9. So what I would do next is I would add the areas of the triangles together. So we've got 7.5, 9, which I'm going to change into 9.0, and 3, which I'm going to change into 3.0. Together, those triangles make 19.5. So next what I'll do is I'll take the area of the square and I'll subtract out the area of those 3 triangles, and what's left will be the area of the pink triangle that we had originally. So I'm going to do 36.0 minus 19.5. And again, you can be using your calculator to do these calculations. That's fine. And we would get 16.5 square units. Okay, so this is using the rectangle around the outside of the figure. Okay, so the next thing we are going to do is we are going to do another problem that is kind of similar to this. So with this one, we're going to do our points first. So we've got 1, negative 4. We've got 5, negative 2. This is P, this is Q. We need 9, negative 4. That's R. 7, negative 8, which is S. And we've got 3, negative 8, which is T. So once again, we are going to connect those lines to create a figure. Okay, so with this figure, we have 1, 2, 3, 4, 5 sides, which makes it a pentagon. 5-sided is a pentagon. Pen means 5. So what we're going to do for this one is we are going to do the same method that we did for the last one, where we're going to draw a rectangle around it, which will create some right triangles. We'll find the area of all of those right triangles and then subtract them from the rectangle. So again, we want our rectangle to go through all of the points and completely surround, oh, I went a little high there, completely surround the figure. So next, and again, I'm going to shade in the original figure that we are trying to find the area of. And I'm going to label my triangles. It doesn't matter which one's which number. I'm just putting 1, 2, 3, 4. So when I find the area, I know which one I'm looking at. I do want to start, though, by finding the area of my rectangle. So length times width. Again, I'll go from this point to this point for the length or the width, either one. 1, 2, 3, 4, 5, 6, 7, 8. Is one dimension, and 1, 2, 3, 4, 5, 6 is the other dimension. So our area's rectangle is 48 square units. Next, I'll do the triangles. So we've got triangle 1, base times height divided by 2. So triangle 1, we've got 1, 2 on one side, 1, 2, 3, 4 on the other. So it's 2 times 4 divided by 2. Or 8 divided by 2, which is 4. Triangle 2, again, base times height divided by 2. Don't forget to be writing down your formulas. We've got 1, 2, and then 1, 2, 3, 4. So it looks like it's going to be the same exact size triangle as the previous one. Okay, and then on the bottom, once again, we have 1, 2, and then 1, 2, 3, 4. And for triangle 4, it's also 1, 2, 1, 2, 3, 4. So instead of showing the work for all of these, what I'm going to do is I'm just going to add 4 4s together, since I know that they're all the same. So I can even write 3 in triangle 4. They're all the same area. So when I add 4 plus 4 plus 4 plus 4, I get a grand total for those 4 triangles surrounding the figure as 16. Since our rectangle's area was 48, I want to subtract out the surrounding triangles to get what's left over. So I would do 48 from the rectangle minus 16 from those outer triangles and get an area of 32 square units for our pentagon. Okay, we've got one more example to look at. Okay, it says two of the coordinates of a rectangle are A, 3, 7, and B, 3, 2. The rectangle has an area of 30 square units. Give the possible locations of the other two vertices by identifying their coordinates. Use the coordinate plane to draw out and check your answer. So, we'll start by putting the 2 points that they give us on there. 3, 7, so over to 3, up to 7. That's A. And then B is 3, 2, so over to 3, up to 2. So, a couple of things from this. We know that the rectangle has an area of 30 square units. So, if we count the length of this side of that rectangle, we see it's 1, 2, 3, 4, 5 units long. Since it's a rectangle, we know that area equals length times width. The area is 30, that's told to us in the problem, and we've counted one side as 5. We'll just call it the width, or the length for now. So we're trying to figure out what number times 5 gives us 30. We can divide both sides by 5. I'm assuming most of us already know what it is, and 30 divided by 5 is 6. So what that means is we want the other 2 points to be 6 units away from the points that already exist. Now there's 2 different possibilities for these pairs of points. We can go 6 points to the right of each of these points. So 1, 2, 3, 4, 5, 6 would put us here. And then 1, 2, 3, 4, 5, 6 puts us here. So now we have a 5 by 6 rectangle, which would give us an area of 30. If we get the coordinate of the other 2 points, we have 9, 2, and we have 9, 7. So those are 2 possibilities for the points. Another way we could do it is instead of moving to the right 6, we can move to the left 6 from those original points. So 1, 2, 3, 4, 5, 6 would put us here. And then 1, 2, 3, 4, 5, 6 would put us here. So again, we are creating another rectangle with 5 by 6 dimensions, which would give us an area of 30. The ordered pairs for these 2 points would be -3, 2, and -3, 7. So either of those 2 pairs of coordinate pairs would make the rectangle that we're looking for. So now what you can do is you can work on your play posit for today to get some practice. Make sure that you are drawing those rectangles outside of the figures and subtracting out the triangles that are given to you to find the area of the figure. Okay, good luck.